I am going to go back 120 years or so. So forget about this century and past century, and I go back to classical physics.
Good for
To
you.
the good old classical physics.
Good old classical.
This stuff. There is a good evidence, I think. There was a question before how we know that the world existed before we are here. The fossil record shows that we, mankind, exist only for 1 or 2 million years ago. And dinosaurs passed away 60 million years ago when we didn't exist. So there is good evidence that the world exists there without we, human beings. Of course, I understand very well. That's very important when we carry out an experiment, yes. But that is something different.
Then,
In my opinion, in my modest opinion, the goal which you have is to find out whether we can understand nature when we do not bother her, when we do not perturb her with our experiments. Of course, we are here. But if we disappear from here, the world will continue going on. When all living things disappear, we will, the universe, the galaxies will stay there. It doesn't matter whether we know them or not. So that's something else. Okay, that's my point of view. And that's a metaphysical assumption. As yours is that it will not. So that's another metaphysical assumption, different from mine. We are in good.
so we respect each other.
Okay, we respect each other. I believe something else, something different.
Yeah.
And that's, I am entitled to do so, as you are entitled to believe that it will disappear when you die. I am with Einstein in this case, that the moon is there when we don't look at it.
Or not.
Although some people don't believe that. That's their opinion. Okay, having said that, of course I speak Spanish, so forgive my English, please. I'm going to talk about unification of gravity and electromagnetism, and I have said here how the unified force arises from anisotropies of the dynamic ether. So, why I have stressed unification? Because when you look at the Berkeley mechanics book, you see that the 2-point particles are described the same for electrostatic and gravitational forces at rest. So they are already, in some way, unified force. It's the same thing. And when you look at the moving point mass, here, I said I was going to go back 120 years back. Heaviside already developed a gravitational theory for moving point path. Before Einstein, and there are some terms that look very similar to relativistic Einstein's STR, special theory of relativity. So, from this point of view, they are already unified. Gravity and electromagnetism are already described by the same equations, both for rest and moving things. So in that sense, there is nothing to unify. Usually, in the 20th century, they will say that it was an analogy, as Heaviside said. And when you look at all the papers that appeared last century, you say an analogy for gravitation and electromagnetism, and there are many, many, many. So, in my point of view, the open question is not how to unify, but what is the common origin of gravity and electromagnetism. We already know that it is possible to explain electromagnetism as a fluid. That is known because at the end of last century, quite a few people, including myself, proposed explaining if there exists a fluid that now is reintroduced. It was forbidden by Einstein. It disappeared from physics. But at the end of last century, it was reintroduced as dark matter through the back door. So, I will assume myself that a good name for dark matter, shorter, is ether. I prefer to talk about a fluid. Dark energy is the energy associated with the motion of that dark matter. Those are particles moving. This is why I'm stressing that we are in a dynamic ether. I never have mentioned that the ether is stationary, as some interpretations there are. That is something that is changing. It is very much like Dirac's sea. It's something moving and changing as the sea is there, or as the air around us is changing. There are tornadoes, there are hurricanes, and everything also that is stationary, apparently. So, the basic laws of mechanics, I prefer to talk about Cartesian mechanics rather than Newtonian mechanics. I used to teach Newtonian mechanics, but I prefer to start teaching mechanics. I used to do that for sometimes from Cartesian laws, which are conservation of linear momentum and conservation of total energy. And in this approach, there is no force anywhere. Force is not there. So this is why when I talk about let us unify force, I am saying it as a concession to our way of thinking, the usual way of thinking, that we believe in force. But what is force? We don't know. Oh, sorry. It jumps. So in Newtonian force, something is here in the earth. We are here. It pulls up, pulls down. Us or a body pulls down, but we have never seen it. We only know the effect. There is another possibility that was proposed in the 1880s, so roughly, by Lesage. He proposed that perhaps we are in a system where what exists is a pushing pressure of something, and that something is dark matter or the good or ether that is pushing down. Down. So, if we are in a swimming pool, or we are here, it's because there is an equilibrium. It is what pushes down and what pushes up. If the equilibrium disappears, we fall. So that is another interpretation of what force is. In my view, there is no asymmetric distance. Everything has to go via contact. And the contact is produced by the change of angular momentum. So when we are hit by a piece of air, we have a sail, it's pushed. We know the phenomenon. So the origin of force is something that is pushing pressure rather than something pulling. So that's what I'm going to talk about. So force is a shortcut name for the momentum exchange. And it's very convenient for that, of course, and we are used to it, so I will keep using it. But in that context, in that particular context, as a short name for the exchange of momentum, linear momentum. So if we look at the macroscopic fluids, as in Cartesian mechanics, we already said that there are two laws, conservation of momentum, and these are the equations of momentum of any macroscopic fluid. You look at any book on fluid mechanics, and you will find this equation, which is the rate of increase of momentum per unit volume, blah, blah, blah. And here you find the gradient of pressure, which is the most interesting thing, and this is the change of momentum due to inelastic processes. This will not enter in a general theory. This is only a local thing associated with our Earth. Otherwise, you don't put that. And what if you look at the conservation of mass? Conservation of mass is just how much mass enters, how much it leaves. But if you change here a little bit, multiply by c, up and down, you find out that this has exactly the same structure as this one here. You have d of momentum relative to w, which is now something with dimensions of distance. So this conservation of mass and this conservation of momentum have the energy, the dimensions of energy length to the 4, And when you put these two things together, you find a tensor equation, a normal tensor equation. So, what is a fluid? A fluid is a formulation of conservation of linear momentum and conservation of energy for a system of many particles. The Cartesian formulation was for one particle, one collision, and here a fluid is for many particles per unit volume. So that's all there is in a fluid. And this equation, when you look at it, is very similar to Einstein's equation. Elizabeth just mentioned a moment ago that was hydrodynamic. Exactly, this is hydrodynamic. A fluid is that. So this is equation similar to Einstein's equation. And here the only interesting part is that this thing is the force. The rate of change of pressure is force. It has the units of force and it's the force. It acts like that. And this is produced by inelastic processes that take kinetic energy in as internal energy. Those are the processes that are there, and there is nothing else there. So when you have that little equation, I proposed that about 15 years ago in Zacatecas in a meeting on CPT and Lorentz forces, and from this, it's easy, from this equation, assuming that that describes a fluid, I'm not saying yet what the fluid is, but I already said that it was similar to dark matter. From there, you can immediately obtain something about metric. This is four-dimensional space, Riemannian space with metric plus. Einstein has metric -1 for the time. I am keeping the 4 dimensions that were there, all them have plus metric. So, the definition of force in a fluid is the gradient of force. This is for one particle. This is the standard definition in classical mechanics. This is the rate of change of momentum, linear momentum. When you have a fluid, you have n particles per unit volume, and then the hydrodynamic pressure is this, which is in the 4D, is just the gradient of the 4D. And from there, one can derive easily the electromagnetic equations. What we do, we recognize the causal quantities. I also believe myself causality. Some people don't. I do believe in causality, so I think any theory of physics has to be based that cause is previous in time to an effect. For that, I already said that I don't believe in causality, in causing things without touching, without contact. But here, these are the causal quantities, which are the current, the vector current. This is the scalar current, and this is the rate of change of charge. They are related to the sources that appear in the fluid. Those are local sources. I will talk about local sources later on. These are the local sources that appear in the fluid. And then, if one recognizes B in the vacuum as the cross product of the gradient here, the rotational, and from there, and you recognize the electric vector as the gradient of B, with those two definitions, you immediately can recover Maxwell equations, exactly Maxwell equations, them all. So Maxwell equations are just a consequence of a fluid for the particular case of inviscid fluid, i.e. when the, sorry, I'm going the wrong direction. When this term is zero, when there are no losses, from the fluid to the internal part of the particles. So in that sense, we already know that it's possible to derive Maxwell equations from a fluid, whatever it is, with some conditions, and if that fluid is dark matter, it's okay. We have electromagnetism. And if we have electromagnetism, already we know from what Heaviside said in 1895, that there were the same equations for gravity, is already the same for gravity. So the fluid gives us immediately gravity and electromagnetism. Simple. That's a unification. Simple one. Without going to quantum mechanics. I said that I'm not going to forget about that. I don't disagree that it works. And that is a very good method of doing calculations. Sure enough, I do that. I know that. I also was trained on that. I know that it works. But I can remind also you that when Copernicus proposed gravitation in a different way, the solar model different to the old Ptolemaic model, for 1 or 2 centuries after Copernicus proposed that, the calculations carried out with Ptolemaic theory were better in accuracy than the calculations carried out with the Neo-Copernican approach. That had to wait until Kepler and Newton, and that finally, after 2 centuries of hard work, it was better than the old wrong. I put wrong in quotation marks because there is nothing wrong in science. It's just a question of the time when it is proposed and the knowledge we had at that time. There is nothing wrong in that sense. That is not correct either. I am Popperian in the sense of Moscovician, that was the first person that proposed the falsifiability theory, method for epistemological acceptance was first proposed by Moscovich, as you certainly know, and was before Popper. But I am Popperian and I am Moscovician in that sense. So any theory is temporary, and we have to go on and on trying to find out a good one. Okay, having said that, I go on. So when I carried out the calculations, I found, I recovered the usual Coulomb force and the usual Lorentz force from the fluid. And I found 2 additional terms that they had to be found. So in a sense, this is very good because this is falsifiable. This makes predictions that can be checked. One of these is this force that it depends on the rate of change of the vector current, and there is one that only exists when this thing is a compressible fluid, which is not around here. That thing should be occurring perhaps in neutron stars or in regions of very high gravity, very high pressure in the universe where the ether is compressed. And this term is non-zero, otherwise. So that is what is recovered from the fluid with 2 new terms. Okay. So what is a solution? I am talking about a fluid. So let me formalize a little bit what I think is the fluid. From my point of view, before this, I had the idea that the fluid was a set of material particles. Now, thinking more about the subject, I am again Moscovician, the methods, I don't know how to pronounce that, decipherment when you... Decipherment. The method of decipherment. So I go and try to decipher what goes on, and I have found that my old idea that there were hard balls of material balls, now I think it's not a good idea. I would think now that the fluid that is there forming the dark matter is a fluid of photons, the lowest energy photons, and this is why now it goes the other way. My goodness. I'm going this. Okay. So I have here the normal electromagnetic spectrum. I have put the photons here. The Sayus. Why I call them Sayus? Because the gravity theory that I am proposing, or I am re-proposing, was first proposed by Lesage. But George Vigier Lesage, a Genevan, in the 1880s, 1780s, sorry, 100 years after Newton, that was 1780s, proposed by the same time that gravity was produced by the flow of very fast particles that will flow towards the Earth or the Sun, whatever, and it was generated, that I'm going to talk next to that, by the attenuation of the science, that I call them science, those particles that he used to call ultramundane, I call them science, because science comes from Lesage, and science and sage in France and in England means wisdom. Is that right?
Yeah, wisdom.
Wisdom.
To be wise, yes.
Something like wise, and so science is something that might bring wisdom at physics level, at that level. Okay? I prefer to call them science to honor Lesage. So, I am suggesting that they are electromagnetic and they have to be in the lower part of the energy, otherwise they will be here and they will be already observed. So those should be something very small. And by the way, to the people that mentioned a moment ago, eclipse and those things, and Elizabeth, I wrote a book on, I ate a book to honor Ale, who was the one who discovered, one of those that discovered strange microscopic effects in eclipses. And it's worth to not mention here that Ale's pendulum had a period of 1 second, 1 hertz, 1 oscillation per second. And that's very curious, because those ions here, it's just a coincidence, this is 1 second and below. Perhaps, one mechanism at work there is some kind of coincidental design of Ale, that his pendulum just entered in resonance with some of the low energy systems that is there. 1 second. Okay. Well, that's just a conjecture. So I am describing the ion as this photon with the smallest energy in nature, and I am assuming that the energy of the ion is C naught before they are first in elastic collision. And that C naught must be larger than C, has to be larger than C, which is the speed of light here in our universe. As I know, we have never measured the speed of the universe of light far away from here, perhaps in the moon, but otherwise we have never measured it actually with an experiment there. So we are assuming that it's the same, but we don't know that. Marguerite that has thought something about that there is perhaps a different speed in previous times. Anyway, so I'm assuming that, and so I have put there the limits for the mass of the ion and the energy in that. Okay. Assume that there is a frontal collision between two things. You know this. This is two macroscopic balls. Do this. That's not very interesting. But what happens if these two things have the same speed? Two equal balls, billiard balls, say, two billiard balls have the same speed, and they collide. And they collide here. There are two solutions, of course, One of them is that they rebound, and the other one is that they stop and rest. Of course, if there are two billiard balls, they cannot merge, because there are no problems regarding penetrability of matter. That's something that Boder also was calling a lot. There are problems with penetrability. And there is also one problem with hard balls. The problem is that if one believes in continuity, that in quantum mechanics they don't, I do believe in continuity, in the sense that if you are going to have a change in nature from a speed b to speed 0, the system had to pass through all the intermediate speeds from b to 0 to be a natural process. And that is impossible if the two walls are hard. And that principle is due to Leibniz. And that was part of the discussion of the old days in that sense. So in that sense, this is the particles cannot be hard because of that. They had to be soft. And this is why I came to the idea they had to be soft and had to be photons rather than material particles, because if they were material particles, they would have to be also soft to allow for all the collisions that we see in nature. So, in this case, if we take this solution as a possibility, and the two colliding particles, photons, stop, then the speed of this becomes 0, occupying some time, of course, until they merge during some time period that the collision lasts, and the final speed is 0, and a photon with 0 speed is not a photon. Photon with 0 speed is something else. And that something else, the only thing we know in the universe, different to space, time, matter, energy is matter. So there has to be matter. So this is the process of materialization. And so you have a possibility of understanding now how energy becomes matter in the universe through a collision, a frontal collision, a head-on collision. They go, stop, and the two things materialize. We already know that process in nuclear physics. I'm a nuclear physicist also. That's the thing that I did a lot during many years. And you see all the time annihilation and pair production. And when you have a photon crosses near to a nucleus, and that photon, if it has more than one eV, it decomposes into an electron and a positron. In this case, the thing just becomes a piece of matter, materializes the same thing. The other case, you can consider that the electron and positron stay there for a little time as an unstable condition, unstable or unstable one. So in this case, it might be a stable condition or unstable, it doesn't matter. But there is a process of materialization. So there is now a possibility then, if we have the whole thing full of an energy sea made out of photons, they can materialize. This is a process that I have never seen before explained, and this is materialization of two photons to form the first particle of matter due to a frontal collision of the two sides. If there are no frontal collisions, you will have the standard things. You have elastic scattering or Compton scattering, whatever. So, in this case, I postulate, Einstein style, that there is a materialization of two ions into matter when there is a frontal collision. And they are converted into a soft atom with red mass equal to that as Einstein. So, we are now in a ionic scheme. The primordial thing, by the way, of course, this is not, of course, a Big Bang. We are in the 19th century. So we are in a universe that is full of something, no Big Bangs at all, nowhere. And there is a possibility for matter creation, for permanent matter creation, as was mentioned before, and everyone mentioned it now and again. So, if two of these, say the red one and this red one, collide, and they form a piece of matter, then that becomes an anisotropy in this isotropic system where everything is homogeneous and very symmetrical in that sense. So, but the interesting thing is if you create a piece of matter, then automatically, instantaneously from the point of view of you, the observer, here, say, oh look, I see now that this and this and this are coming here. The other one doesn't, they go somewhere else. They don't matter for this. They don't matter for this. But these are coming here. So, but these that are coming here look very much Gaussian. You see, this is a spherical thing created by the presence of this. The other doesn't matter, but now you see that there are radial things coming here. And so on, you can apply Gauss theorems here, nicely. And you know that because the Gauss theorem is 1 over r squared, immediately. So, immediately when there is an isotropy created by materialization of a pair of ions to become a soft atom of matter, then immediately you have that. And from there, you can have now a process, a very simple process. Well, already say this. You can see now that from this point, you find a lot of them coming there, and some of them in another direction that doesn't matter. But now what happens if, but here you cannot say anything more until you have another point somewhere to determine direction. So you need another one to fix direction. So assume that you find that there is another point somewhere here, so that you can put here in this space direction. If you put direction here, what happens? You can now analyze what happens in every angular direction. Say here, green and green, it is in equilibrium, so there are no forces in that direction. Well, what happens here in this that I put here? There are two coming here and eventually one coming here. So this will push down and this will push up. So this automatically generates a line of force downward. And this is our vertical in this earth, for instance, or anywhere else. So in this sense, force, gravitational force, is just an unbalance in the flow of either science, whatever. It doesn't matter how you call it. It might be particles also. It doesn't matter really the exact nature of this for the time being. For this, it might be anything. So when there is an imbalance, you will have that, which is already what I showed with equations before, with the equations of the fluids. And what happens then when you have the first particle here, and there is another photon coming in? What may happen? Might happen that thing collides elastically or inelastically, it comes one side or the other. But if there is a frontal collision, it may be absorbed. And if it is absorbed, then you have coalescence. And you have now 3 pieces of that. And the velocity of this will be something like this. And this speed, you can immediately see, that will be always smaller than the local c. That sounds very much like Einstein's rule that the maximum speed for a particle is less than c. So perhaps what we are having here is an average speed of c in this area of the world that we interpret as the maximum velocity or the maximum speed. And this is why, because you cannot transfer more speed to this after many, many collisions, and the limit will be this. And the limit will be always less than c, always. So now you have a nice connection with STR, special theory of relativity, with that particular point. And also you can see that this thing increases mass and increases velocity, but the two things are not a consequence of the other. They are related, but they are not causally related. They are only parallel. Something like that. So this is what I'm saying here. This is the V, how it increases, and you will have this condition, which is consistent with what is observed in laboratory. So I already said that there are also other collisions for photons or whatever. This is well known in the field of gamma radiation and matter. There are many collisions, so there is nothing new there. Everything is as usual. So what is the mechanism of the size for gravity generation? It's already implicit in what I have said. If you have here now a big ball, like the Earth or the Sun, you have here part of the rays coming from that direction are scattered or absorbed, they are attenuated, and those that come from the other direction are the same. But then if you are located here, what happens? That the Earth is attenuating the system coming from this direction, and so depending on the distance you are from the Earth, you will have a larger area or a smaller area of, and that modifies the number of the fluid particles coming in, and modifying the number of fluid particles, you automatically modify the apparent force. And then you have, with this, the 1 over r squared dependence that is standard. And this is because this is a spherical body. So, in this context, the 1 over r squared depends on the very fact that we are near a spherical star. If we are in another region of the universe dominated by something else, for instance a galaxy that is like this, and you look at the galaxy from this, or it doesn't matter how you look at this, that won't be overall a spherical thing. That will be a different geometrical shape. And so the shadow that these things makes in this side of where the observer is will be different. And then that will be immediately connected to the well-known discovery by Vigier that the rotational velocity is different when you go from here up there to the galaxy. So the flat galaxy rotation velocity is explained with a different shape. So if you have now, say, a flat one, you will find a different situation in which the number of attenuated rays from one side is different from the other side, completely different. And I made some preliminary calculations. They are published in the book of Array in 2011. I will show them. So when you are in spherical geometry, you will find that you find immediately in spherical geometry, you have the Newtonian quantity. You have here a definition of G as a function of shapes. This is something very well known. That was a very large research during the 90s, 85 to 90, to the end of the 90s, when they found variations of G as a function of how you determine G. And so this is consistent with that. And there is also a new term there, a small term, but it's an addition to Newtonian gravity. And there is a small term that is fairly small, but there is a small term that is also there. And when you are in a collimated geometry, which is the flat geometry I showed you a moment ago, you have two different terms, and those terms, especially this term here, this term, which is in the limit is something like this term, which in the limit is something like this. This also explains then how a system can be stable and can have a very different equation to Newtonian. This is non-Newtonian, but it's also according to well-known theorems of dynamics, leads to a stable system which are either 1 over r squared or linear in r. So they lead to stable gravitationally bound systems. So these are the two main things related to geometry. And there is one thing I just want to mention in passing, is this.
1 minute.
1 minute. The other thing I want to mention is that the Einstein's assumption that there is a gravitational mass equivalent to inertial mass which is independent of composition, according to the results of the August Beckett experiment revised by Fishbach in the 80s, this is their revision, and they found a clear dependence of composition in their gravitational mass. Very clear dependence of composition. And that is implicit and built in the model I developed for the size. And I can predict that. You can see this is my prediction. This is my prediction for the same data of EPR with my Vigier model. It's completely good at 92% correlation for the data of feedback. So that is all regarding the Einsteinian thing. And so this is, thank you very much for your attention. This is our world. This is the world up there. Good. Good.
We'll have to go on straight on to the next talk because we've run out of time. So over to you, Martin. The next speaker